Thank you very much. Hello, everybody. Thank you very much for coming to my presentation. I'm going to be talking about some of the developments that are happening around cloud-native application development, around Kubernetes, and also especially OpenShift. OpenShift is Red Hat's container platform, which has Kubernetes at its heart. So first of all, let's spend a couple of minutes talking about Red Hat's business and our open hybrid strategy and the 3 pillars thereof. So everybody, well, most people here probably knows Red Hat is the leader in open source in the industry, right? But a lot of people come to me and they ask, well, what does that mean? What does Red Hat do, and what does open source mean? So if I put it very simply, or if I try to put it in a nutshell for you, Red Hat turns projects into products. So what do I mean? Projects into products. Red Hat works in some of the very promising open source communities, and we contribute and we create software together in the community, and we test that software and we fix that software, and we create fixes. The fixes go back into the community for the benefit of everybody. We then bring that software and we turn it into a product, right? And the product is consumable for the enterprise. So Red Hat started about the mid-90s. We started with, of course, as you all know, with Linux, right? And we now have the product Red Hat Enterprise Linux. So the past 10 years, we have also been focusing on cloud software. And we have been working in some of the most vibrant communities out there. For example, OpenStack and Kubernetes. And these are our 3 pillars of our business, and we're focusing on open hybrid cloud. So a lot of people come and say, well, what is the product of open hybrid cloud? It's not actually a product, it's actually a concept or a strategy. And the first pillar is hybrid cloud infrastructure. So we want to make it really easy for you to deploy your cloud platform onto any of the 4 footprints. And the 4 footprints being public cloud, private cloud, virtualization, and even on physical, bare metal. And the second pillar is cloud-native application platform. So we want to make it really easy for developers to bring their source code, bring their applications, and easily get them running on our platforms. And then also, management and automation. We want to make it as easy to manage our platforms, just like you're using a public cloud service, as easy as that. So looking at cloud-native app platform, our vision is to simplify the creation of these cloud-native applications, including serverless, so the developer can bring these applications to the platform without having a deep knowledge of Kubernetes. So how are we doing that? We're creating tools and standards, processes to increase the developer productivity on Kubernetes. And also, we are creating automations on Kubernetes, especially with application operations and with DevOps in mind. So I'm sure most of you would agree here that developers, they are the ones who bring in the new technologies into their organizations because they want the latest cutting-edge technologies. They want to create the latest thing, right? They also want to make their life easier. So in this survey with Evans Data Corp, 58% of the developers said they are the primary decision makers for deciding on which container platform to use. And software development is also changing. No longer are we all building monolithic applications and building those on our own local workstations and desktops, using a single language or runtime, and also creating our own processes on our own laptops, for example. We are working in a distributed world, right? So we might be using, looking at hybrid cloud. Perhaps we are adopting containers. Also, if we have many teams, we're developing for microservices architecture. Possibly we are using many different languages and runtimes as well. So this brings many challenges. So in this survey, the developers were saying configuration and setup of their development environments is taking them 24% of their time. That's a quarter of each day just configuring and setting up their development environments. And then 41% of companies said that tool integration with container platforms is a problem for them. So what is Red Hat's approach to developer tooling? If you are developing your applications to be running in containers, you're running them on a container platform, and possibly also you might be building your applications in containers on the same platform as well. If you're doing that, why not also develop your applications in containers? So you can take advantage of the strengths of container technology, that being repeatability and also shareability. So being able to repeat container technology means that it is very easy to deploy development environments using containers. We can also use the shareability to enable teams and developers to make better decisions. And also Red Hat is working to improve and standardize on these processes so that developers don't need to create their own processes themselves. So let's take a look at the OpenShift ecosystem. But first, some of you, I'm sure most of you, all of you know what Kubernetes is, right? But some of you might not have heard of OpenShift. OpenShift is Red Hat's cloud container platform based on Kubernetes. And right now we have over 1,000 customers, most of them using it in production. And the two main reasons why customers come to us are, first of all, you can deploy OpenShift anywhere. Right? You can deploy it on any of those 4 footprints I mentioned. And the other reason is for the ecosystem. We have a very, very vibrant ecosystem, both in the open source communities and also in our partners. We have a lot of partners who provide their solutions and services on top of OpenShift. So this is a snapshot of the ecosystem from a developer's perspective. So I'll go from top to bottom. First of all, function as a service. Red Hat is going to provide a FaaS service called Red Hat Cloud Functions, and it is going to be based on Knative. So Red Hat is embracing Knative, and Knative brings the primitives that are needed: events, build, and serving. And then Red Hat is also bringing on board other tooling, for example, ODO, command line interface, and also Eclipse Che. I'll talk about that in a while. And then Red Hat has a whole host of middleware products. They are all certified to run in containers on top of OpenShift. Like I mentioned before, the ISV services and our partner ecosystem. We have a very vibrant partner ecosystem providing services for which are certified to run on OpenShift. And all of these things will be running on an operator framework. So very briefly, the operator framework is a new technology which promises to make it much easier to run and manage stateful applications, complex stateful applications on top of Kubernetes. I'll be talking about that later. Also, Istio. So Red Hat is going to offer a service mesh which will help you manage your microservices architectures. And then all of this is based on top of vanilla standard Kubernetes. So we do not fork Kubernetes. Many people have said that we fork Kubernetes, but we don't. So every time we make a new release of OpenShift, we take the latest version of Kubernetes, we recompile it, and we link in our extensions. So some of the examples of our extensions are on the slide. For example, being able to install and manage the operations of hybrid installations or clusters of OpenShift. Making it easy to install and upgrade the cluster. Adding developer and operations consoles, web interfaces to the cluster. And of course, very important is security. So Red Hat, from the very beginning, 3 years ago, worked heavily in security, added things like authentication, role-based access control, all the things which we know that our customers, our enterprise customers, need. And if you look at this diagram and you imagine that is your house, if you want to build your house, you need to build your house on a solid, trusted foundation. And that foundation is Red Hat Enterprise Linux. Or today, we also have Red Hat CoreOS, which is a cut-down version of RHEL, which is made just to run containers. Now, containers are Linux. Containers inherently run in the Linux kernel. Containers do not run in the Kubernetes layer. like many people think. So you have to have a strong, trusted foundation, and that foundation is Red Hat Enterprise Linux. All of our products are based on Red Hat Enterprise Linux. So let's have a look at some of the developer tooling. Today, developers, they need to oftentimes have to manage their own workstations, manage their own laptops, download the IDEs, download their tools, install it, and manage it themselves. Isn't there a better way to do that? Shouldn't they, in the world of cloud-based services, they should be using cloud-based tools to do development? So, code-ready workspaces. These are developer workspaces which run in containers. And they can be running in containers in the public cloud, and they can also be running on-premise. And it's based on Eclipse Che. Eclipse Che is a web-based IDE, and it's a development environment running in pods. And this feature, like many other add-on features around OpenShift, come included with the platform at no extra cost. So code-ready workspaces leverage the strengths of container technology. Like I mentioned before, the strengths of repeatability and shareability. So for example, it's very easy, because of repeatability, I can very easily deploy a development environment for a new employee or a new team. I just need to roll out the container images, and then I have my environment. And I can also share my development environments. Imagine I have an environment and I have a specific problem. I can share that with the testing team, and we can compare the situation and maybe even remove the problem if it works on my machine. And then the other thing is, for companies that are very sensitive about their source code, they can keep the source code centralized on the platform. There's no need for them to worry about managing the source code and worrying about the source code on all the developer laptops. So you use this to simplify container-based development and increase efficiency. So coming to another tool, ODO, which is short for OpenShift Do. Remember I said we want to enable developers to easily bring their code and applications onto the platform. This is one of those tools. So with this tool, as you can see in the example, top line, I'm creating a backend with Wildfly, and then I'm pushing some source code to that, and it builds the application and launches the application in a container. And then optionally, I can add some storage if I need it. And then I'm building a PHP front end, doing the same thing, adding some code, building that service. Those backend and front end will be automatically linked together. And then with ODO URL create, I can very easily get a URL, which I can use to test my application. And then with ODO watch, that means any local changes in the code will automatically be synchronized with the running container. So if you do need to still run OpenShift on your workstation or on your laptop, so container technology is very lightweight, so you can do that. You can actually run OpenShift as a cluster on your laptop. You have these choices. So for version 3 of OpenShift, you can use the container development kit that allows you to run a real version of RHEL in a VM with OpenShift running. Or for OpenShift 4, you can use the new code-ready containers. So Knative, like I said, Red Hat is embracing Knative. Now I find the open source world fascinating, right? Sometimes great ideas come along and they are adopted. And then soon after, another great idea comes along and kind of squashes or trumps the old ideas. I find Knative is a great idea personally, and also Red Hat is embracing it. So it is a way to extend the Kubernetes API so that you can create serverless applications, and you can do it without having to reinvent the wheel. So what it provides you, for example, is build. You can build and bring your source code to the platform and get it running, and serving. You can run your application. You can even scale it down to 0. And then eventing. You can stimulate your event-based application. And what could developers also have from Knative? Knative pipelines. With that, they can build continuous integration quite natively and build that natively into the platform, Kubernetes platform. And also the OpenShift Cloud Functions That is Red Hat's function as a service offering, which will be GA in a few months' time. That will be highly integrated with the OpenShift DevOps console. It'll be integrated with the workspaces, the code-ready workspaces, and also the ODO tool and other IDE plugins. So this brings me to operators. Now, you may probably have not heard of operators. This is a new technology in the Kubernetes community. It originated from CoreOS, and CoreOS is the company which Red Hat acquired last year. So operators allow you to more easily deploy and manage complex stateful applications. And I mean something like a clustered database, something like MongoDB or Redis. And operators, now if you remember nothing about this presentation, just remember this, that operators promise to bring a public cloud experience or a public cloud-like experience on top of Kubernetes. So what do I mean by that? We all know and love some of the services from Amazon Web Services, right? And one of my favorites is Relational Database Service, RDS. So with RDS, I can very easily spin up a database. I can start it and stop it. I can back it up. I can restore it. I can scale it. All these things, right? This experience, operators are promising that same experience, right? Whether it be an operator for MongoDB, whether it be an operator for Redis, or whether it be an operator for something like etcd, any complex stateful application. So operators are, in another way to describe it, is knowledge in a box. So we're again using the strengths of container technology to our advantage. Imagine, for example, this fellow here is a database administrator. We can take his experience and knowledge of how to operate a database and put that into a container image. So we encapsulate, burn that into a container image. And the great thing about the image is it can be shared. So we can share that image, and others can use that experience. So operators are automated software managers. Operators know how to install, not just install, but they also know how to work and manage the life cycle of a complex application. Like I said, like similar to RDS, backup, scale, restore, all these types of things. So here's an example. An operator is essentially a controller, and it is extending the Kubernetes API. So it's extending the functionality of Kubernetes. And if I want to use an operator, I install the operator into my Kubernetes cluster, here in the example. And this is an example of a custom resource definition. So CRD. CRD is a way for me to extend the Kubernetes API. And in this example, I have a YAML file, and I have my production-ready database. So I'm going to create an instance of my database. And to do that, I have my file, and I give it a name, my production-ready database. And I want to configure my database. I say I want to have a cluster size of 3, and maybe read replicas, I want to have 2, and I want to use this particular version. So I then take this YAML file, and I instantiate that as an object in Kubernetes, pass it into Kubernetes. The operator will then see, or notice that there's a request to start this production database, and it will go ahead and create all of the core objects, the Kubernetes objects which are needed to start my database. So it'll start the 3 pods, might start some service objects, might start some stateful sets, all the things that are needed to run my complex stateful application. And then the operator will stay there and watching for any change in the desired state. So for example, I might want to scale my database. I might want to add another pod. And if the operator was to do that, it would add another pod, and maybe it would have to rebalance the data within the database. So this is things that the operator can do. If you're interested, you can come to the Red Hat booth later, and I can show you exactly that happening with the Couchbase operator. So like Docker Hub was a great innovation, a great way to share container images. About 6 weeks ago, we launched Operator Hub. This is a great place where you can share operators. And in the operator hub, we have community operators, operators from some of our ISV partners, and from Red Hat ourselves. And all of this is integrated into the OpenShift console. So the developer can come to the console, find the operators, find the service catalogs and the brokers, which they're used to, and even source to image builders to create and build their applications. And you can view the operator marketplace from within the console as well. Now, UI extensions, this is something very interesting. So these are powered by operators. Now, if you could imagine a system, a platform like OpenShift, it could become very complex, and it could become very bloated with features. Now, so we can use operators to avoid that. So if, for example, the system administrator wants to offer service mesh to the users of the platform, all they need to do is install the service mesh operators. In the top left here, you can see an example of the service mesh. So the administrator would install the operator, and only then the service mesh would become part of the platform and would be available to the users. If the administrator doesn't need the service mesh, he doesn't need to install the operator. And then another example is container native virtualization. And just as a side note, you will be able to soon run virtual machines also on the same platform alongside your containers. So if an administrator wants this feature, just needs to install the operator and make it available on the platform. And then another important point is on the bottom right, metering and chargeback. So because the operator has an intimate knowledge of the application, it can also check for usage. So utilization of that particular application and measure and basically provide metering and chargeback. You can go today to operatorhub.io and you can have a look at the operators in there. So when I checked recently, not on Operator Hub, but when I checked recently in the open source, in the communities, I saw 200, well over 200 operators being created for all different types of technologies. And here are just a couple of the examples of the technologies for which operators are being created. So another technology which Red Hat is providing is the service mesh. So what is a service mesh? If you are running dozens or even hundreds of services on your platform, how do you manage them? How do you know if they are working? How do you secure them? How do you implement authentication and access control for your microservices? All of these things can be implemented using a service mesh. The thing is about the Istio service mesh is that it takes away a lot of this burden from the developers and it pushes it down a layer into the infrastructure layer. So this is the collection of tools which Red Hat will provide. It's kind of like a mini distribution for a service mesh. Of course, it's made up of Istio. Istio is providing the Envoy sidecar technology. It's also integrated with Jaeger. Jaeger provides the ability for you to know exactly how much time your services are spending. You can drill down into each of these so-called spans, and you can see right down to which pod, which container was processing at that particular time. Also, we have Prometheus and Grafana, so you can actually visualize what's going on, what's happening inside your mesh. And then also we have a product called Kiali. This is a user interface, bottom left, which you can use to visualize the topology of your microservices mesh. Kiali will automatically determine the topology of your system. It will show you the quality of your connections between the services, so you can very easily, or more easily, find bottlenecks. You can visually find those bottlenecks with that. So, like many of the tools, like many of the services with OpenShift 4, it is operator-based also. So that brings us to OpenShift 4. So OpenShift 4 has all the great features and functionality of OpenShift 3, but for OpenShift 4, we've been focusing on manageability. So quite honestly, OpenShift 3 has not been the easiest to maintain and patch and upgrade. But OpenShift 4, we're changing that. So OpenShift 4 is able to manage itself, and it uses a lot of operator technology to do that. For example, it has operators to be able to manage the underlying infrastructure. So on Amazon Web Services, it's able to manage the underlying instances in all of the 3 availability zones, and it's able to scale those instances. So automatically scale them depending on utilization of your applications. And should one of those instances fail, it's able to self-heal that instance. Just like it self-heals pods, it's able to also self-heal instances. And it will work the same way, not just on Amazon, but on other clouds, and also on private clouds, on VMware, and even on bare metal. So we're promising also the same experience on bare metal. So there's a new and improved installation process. This is a tool that you can download from try.openshift.com. So try.openshift.com, you can download the tool, and very quickly, within about half an hour, you can get OpenShift 4. This is a developer preview, by the way, so you can install OpenShift 4 into your own Amazon account. And it works kind of like a wizard. It simply asks the questions that it needs. It asks me for my key. It asks me where I want to deploy, and maybe which region, and the name of the cluster, and so forth. So OpenShift 4 also allows for what we call over-the-air updates. So we're, again, using the strengths of container technology to provide updates for the cluster, for the OpenShift cluster. And the updates come in the form of images. All of the material needed to update the cluster is in the image. And also the operator. The operator, for every single update, the operator encapsulates the knowledge on how to upgrade the cluster. And then, of course, a lot of our customers don't have the luxury of being able to access directly over the internet the Red Hat Container Registry to make those updates. So they might have air-gapped environments. But still, this is going to be greatly simplified. It's simply a matter of accessing the container registry, synchronizing those images, those update payloads, passing those through the file into a local container registry, and then the process continues from there using the over-the-air updates, the same way as what the example I just showed. And then we have the Kubernetes Cloud API. So this is a way for users to be able to deploy Kubernetes onto all of these different footprints. So in this example, Amazon, VMware, OpenStack, and many others as well. So users need to have the flexibility to deploy their application where they want. Not just deploy it and leave it there, but also to be able to change that. If I put that Amazon today, maybe tomorrow I want to put it on-premise on VMware. So this provides a consistent view, and it also helps you manage the underlying infrastructure and with auto-scaling, and it helps with resilience, increasing the resilience of your infrastructure. Now, we're going to call this OpenShift Hive. This is our solution using that Cloud API. And this is a way to essentially make OpenShift manage multiple clusters of OpenShift. And in this example, you can see here, this is a custom resource definition, and it's defining exactly the configuration of a cluster. So I would use this definition to deploy my clusters. And we're using technology, for example, like I mentioned, the Kubernetes Cluster API, but also Kubernetes Federation, which allows you to manage multiple clusters. And like everything that Red Hat does, everything Red Hat has is in the open. So you can actually have a look at the source code today. You can have a look at the discussions between the developers. You can even get involved yourselves, right? We encourage everybody to get involved. So you can go to github.com, OpenShift/Hive, and you can have a look and try this technology. So that brings me slowly to the end of my presentations. I would really welcome you to come to the Red Hat booth, because I can show a lot of these technologies live. So please do come along this afternoon. And I hope you have enjoyed my presentation. Thank you very much for listening.